Okay, last week we learned about something on the scale, ports, arithmetic logics, and things like that. Today we'll do some exercise about the arithmetic commands. We'll start from addition command. In the lecture notes, we have an example here. We have two 16-bit number. Please remember the numbers of x in 78 hex and 79 hex, and number of y 7a hex and 7b hex. First of all, we have to write those numbers to the RAM, and then we will do addition operation. Let's do it together. Maybe we can copy from here some program routines and then program code. Okay, that's all. First of all, we can do this operation on the screen with our hand, right? How can we do it? Okay, the first number is 1, 2, 3, 4 hex, and the second number is 1, 2, E and FX. And if we add these two numbers, we will start from the lower significant digits. 4 plus F, it will be 19, and we have 3 and 1 of the carry. 1 of carry will be 4 plus E, it will be 18, I think, yes. And we have 2 here and 1 of carry from this addition. If we didn't consider the carry, the high byte or the addition of the high byte will be 24. You can see here. If we don't consider, the result will be 14, right? But if we consider here carry bit, it will be 25. Okay, the result should be 2523 hex. Okay, we know it. Let's do it together. First of all, maybe we can try here. We can use add command. What will be happen? Compile this program. Okay, then after the compiling, we can go to the debug session part. Here we have RAM area. Maybe we can check the memory here. We have 4 memory cell, including those numbers. Let's execute the program step by step. Now we are in line 2, and then 78 hex will be 14 hex, as you see, 12 hex, EFX, and 12x. Okay, those numbers are our numbers: x low, x high, y low, y high. And then we have to get the first number, which is addition. So a will be 14 hex. It is low byte or the x, and then we know it. In 7a hex we have y low value. So if we add these two numbers, as you see here, program status word carry flag will be 1. Okay, maybe we can do it again. at the starting of the program, carry flag will be 0. Okay, and then if we execute this program until this line, carry flag is still 0, but if we execute this line, x low plus y low, carry flag will be 1. Okay, as you see here, carry flag will be 1, and result is 23. As we calculate before, the low bytes addition will be 23 hex, and we have also 1 carry. Okay, then we have to write this result to the x low where in 78 hex. 78 hex has 23 hex value, which is the result of the low byte. And then we have to get high byte of the addition, which is 12. And in here we used add command. Add command don't consider the carry flag, so the result should be 24 hex. But actually it should be 25 hex, right? So in here we have to use add with carry, but we used add command. Let's check it now. As you see here, after this command, the result should be 24 hex, which is wrong answer for us, and also carry flag will be 0. Why? Because we have a new addition here, 12 plus 12 hex. So after this command, we have no carry. So the result will be 14 hex, and the result will be written to the x high value where in 29 hex. Okay, 23, 24. Quit the debug session part, and now we can try add with carry. On this condition, we will consider the carry flag and result should be 25x. Let's try it. After the compiling, we have no error, no warning. We can go to the debug session part. This line is the same. Actually, until this line, all of them is the same. So we can execute the program up to line 12 with this icon, run to cursor line. And then as you see, we have carry value and A is 23, 78 hex also 23 hex value. We will get the high byte of the addition, and then here we will use add with carry command. So we expect that the result should be 25x because of the carry flag. As you see here, A is 25x, which is the result for us, correct result. So the new value of the result 2523 hex, okay, which we calculated before. Another example is about the subtraction command. Let's get it. Now, operation is x minus y, and both of them are 16 bits. Number 1, 2, 3, 4 hex, 1, 1, 3, 5 hex. Let's copy it to the program. We don't have sub with carry command because sub command is already considered the carry flag, as I said before, because subtraction operation has the borrow concept. Okay, if we don't have enough, so we have to get a carry value. Okay, what should be the result? First of all, maybe we can do it. 1, 2, 3, 4 minus 1, 1, 3, 5. 4 minus 5. What is the result? We don't have enough, so we have to get a borrow from the most significant bit, which is here. So we have 16 plus 4, 20. 20 minus 5, it will be F. Okay. And then we have here 2 now because we get a borrow 2 minus 3. It is not possible, low byte and high byte. It is not possible, so we have to get one borrow again from the most significant bit, which is carry for us. And then we have 16. In here we have also 2. 16 plus 2, it will be 18. 18 minus 3, the result will be F. Okay, and carry is set. Subtraction operation is already considered the carry flag. So if you do 12 minus 11 operation, we have also one carry flag. The result will be 0, 0 hex. Okay. Now we can do this operation. It should be 0, 0 FF. We expect this. But please remember, be careful about it. If you do a subtraction operation, before the operation, clear the C value. Okay. If it is affected before, the result will be wrong. Okay. So we have to clear carry flag before. Until this line, initial values will be loaded. Yes, as you see, the initial value will be loaded. The first value will be obtained to the A, and then we will subtract the second value, which is EF here. Sorry, 35 hex. Where is it? Okay, in here we have a warning. If you run your program to the cursor line, you have to use a program line, okay, not blank line. Please use a commas line. Here we have to use line 9, for example. If we use line 8, program will continue. You can see the program will continue as like that. Okay. So we don't want to from program as like that. We want to get line 9 until line 9, and if you use a command line, program will continue up to this line. Okay, we will get the first value to the A, 34 hex, and then second value will be decreased from it. The result is FFX. What about the carry? Carry is 1, as you see. We get a borrow from the most significant bit. So the result will be loaded to the XLOW again, 78 hex. The second value, which is high value of the X, is obtained to the A, 12. 12 minus 11, right? But we have also a carry value, so the result will be 0. Okay, A is 0, carry flag is 0 now, and the result will be written to the X high, which is 79 hex. That's all. Okay, what about next? Increase and decrease commands. Maybe we can do about this. Okay, we can do an example about this program. This program is about addition of two vectors. As I said before, assume that x value is starting from 30 hex. Okay, y is starting from 40 hex. Let's do an example, and each of them including 16 memory cell. Okay, but first of all we have to write some numbers to each one. Okay, we can do it. Move R0 30 hex. Move R1 40 hex. Move at R0, write a number such as maybe 90 hex. Move R1, assume that we'll write 80 hex. Okay, maybe we can use a counter. Move R2 16 decimal. Because of the we have 16 memory cell, and then increase R0, increase R1, decrement jump if not 0, R2, where X, where's X? Here. What is the operation here? First of all, we have to write some values to the related memory cell. We assumed X vector starting from 30 hex, Y vector starting from 40 hex, and each of them has 16 memory cell. Okay, so we write some numbers. For the X value, we write 90 hex for each cell, and for the Y value we wrote 80 hex value for each cell, and we have a counter here. Counter, why we use? Because we have to do this operation 16 times. Okay, so because of this reason we used a counter, and for this counter, for each loop decrease by 1 of this counter, and then we will continue to the right the other numbers. Maybe we can try it before. Okay, we don't have any error and any warning. Size de göndereyim. I shared with you from the message box, and then we can go to the debug session part. Okay, the related memory cell 40 hex and 30 hex. Maybe we can organize the memories window as like that. Okay, 30 hex, 40 hex. Let's execute the command step by step. R2 is 16, which means 10 hexadecimal. We are continue now. R0 is 30 hex, R1 is 40 hex, and then the first value of the X will be written to the related memory, and second one Y value is written to the memory, and then increase R0, increase R1, and decrease the R2 value, which is 0fx, and then it will continue as like that. You can follow this memory cell, please. Okay, as you see here, we are in line 13, and all of the numbers are written to the related memory cell. Okay, so we can continue to the program. What is the operation? Now we can know this operation. Read the x value, first x value, and add to the y value, first y value, and then result will be written to the x value. We can know this operation now. We can copy it to the program, but before we have to arrange R0 and R1 value again, because the first value of them will 30 hex and 40 hex. Okay, how many times we can do it? Again, we have to use counter. We can use the same counter again. X, we used X before. Maybe we can use X1 here. Where is the X1? X1 is here. X1. I think that's all, but let me check this program. Okay, I think it is true. Let's build it. We have no error and no warning. We have already done all of this operation, so we can execute the program code line 12. Okay, and as you see here, all memory cell has the values, initial values. What is the operation? It will be added to each other. What is the result? 90 plus 80. Let's do it before. Maybe we can write here 90 hex plus 80 hex. What is the result? We have one carry. Okay, 90 plus 80. It will be 10 hex and one carry. Okay, one carry, and the result will be 10 hex. All of the result will be written to the X again. Where is X? 30 hex address. Let's do this. The first value is obtained to A, which is 90 hex from the first value of X. And then, as you see here, the result will be 10 hex and carry flag will be 1. Okay. If we continue as like that, all of the X memory cells, please follow this line. Okay, although the X memory cell will be 10 hex. The counter is 3 and I will continue. Yes, counter is 1, which is R2, and we have only one operation from here. Yes, the last operation will be done, and counter R, where is counter? Counter R 0 now, and the program will in endless loop. Let's continue now from the multiplication and division operation. Move A, for example, 40 hex. That is a sign, of course. Move B 10 hex. Move AB, or maybe we can use more easy numbers. Move AB and then div AB. What do you think? In this line, what will be result? What do you think? What is the result? Okay, let's do this question together. What is the number? We are in hexadecimal number system, 40 hex times weight 2 hex. What is the result? 80 hex. Okay, we don't have any carry. As you see here, after the multiplication command, the integer part of the result will be written to the A and the remaining part will be written to the B. Okay, so what is the result? 80 hex. A will be 80 hex. And what about B? We have no remaining part. It will be 00 hex. Here, after the multiplication, the low byte of the result will be written to the A. The high bytes of the result will be written to the B. Sorry about that. The high byte of the result will be 00 hex, so B will be 00. And then we used div AB command. The new value of the A 80 hex, but we have 00 about the B. If you do this operation, the problem will not be solve this question. Okay, so I think A and B will be the same, but overflow flag will be set. After the multiplication command, overflow will be 0. Okay, because we have no overflow from the low bytes of the result. Okay, multiplication command and division command, overflow flag, if the result is greater than ffx, overflow flag is set. Okay, what about division command? Overflow flag specify the 0 division status, so if there is a 0 in the B register before this command, the result ambiguous and overflow flag will be set. Okay, let's compile this program and go to the debug session part, and we'll continue step by step. A is 40 hex, B is 02 hex. After the multiplication command, as you see, A is 80 hex and B is 00 hex. What about overflow flag? In the program status word, you can check the overflow flag value in here. Overflow is 0. And we are in line 6. If you execute this line, A is the same, B is the same, but overflow flag is 1. Okay, which specifies the zero dividing condition. Okay. Do we have any problem about the multiplication and division command? Maybe we can try this program with a higher value, not the same. Overflow is the, as I remembered, second bit of the program status word, but carry flag is seventh bit of the program status word. Okay. For the division command, carry flag is always cleared. For the multiplication command, the result cannot be greater than fx, so carry flag will never be 1, unaffected. The new value of the a and b, a is a0 hex, b is 20 hex. Okay, if you do multiplication operation for this question, it will be 1400, but maybe we can try another number because we don't want to zero value from b. Let's do this again. A0 times with 21. Result will be 14A0. Okay, A will be A0, B will be 14 hex, because the low byte of the result will be written A and high byte of the result will be written B. And if we do this operation now, overflow flag will be 1. Okay, if we divide A0 to 14, what will be happen? The result will be 8. Result will be 8. We don't know about B because it is the remaining part. Okay, we don't have to calculate this value, but we know it. Overflow flag will be 0 because we don't have any zero dividing condition here. Let's execute this program and then we can go to the debug session part. The initial values of the A and B are obtained as you see here, and after the multiplication command, let's check the program status value here. Yes, overflow flag is 0 before the multiplication command. Okay. Yes, after the multiplication command, A is A0, B is 14, and overflow flag is set. Carry flag is 0 as you see. Okay. After the division command, A is 8, B is 0 because of the remaining part is 0, and overflow flag is 0. Okay, that's all. Here we have an example. Syntax error, where is it? We don't have to use space. Yes, the number is 21 hex, which means 33 decimal, and the first value is as like that. And if we do a rotating left operation, it will be times with 2, which means 66. Okay, maybe we can check it here. 21 hex and 42 hex times with 2. Okay, not decimal number system. If we do this operation again, second shifting, what will be happen? 84 hex, which means again times with 2. If we do one more time rotating left, we will get wrong answer. Why? Because as I said before, if the zeroth bit of the accumulator is 1, result will be wrong. Okay, so if we do one more time, result is 9 hex, which is not times with 2 of the 84 hex. So if we use here rotate left with carry, here if we use rotate left with carry, and if we consider the carry after the operation, we can get the correct answer. A is 8 plus with 2 to power of 8 because of the carry flag. Okay, you can evaluate us like that. What about rotate right command? Quit the debug session part. Rotate right means we will do dividing by 2 operation. The first value of A is 82 hex, which means 52 hexadecimal number system, 52. Okay, if we divide this number by 2, it will be 29. Let's check it. Yes, 29 hex. If we do one more time this operation, what will be happen? Divide by 2, it should be 14. But what will be happen now? Let's check it. The result is 94 hex, which means 148 decimal. Wrong answer. Why? For the rotating right command, if we have 1 of the for the 7th bit of the accumulator, the result will be wrong. Okay, result will be wrong. How can we do it? If we do rotate right with carry of this operation, we'll get the correct answer. Let's do it now. Rotate right with carry, and after that clear C, and if we do one more time this operation, what we get, let's check it. Okay, the first value, initial value, is loaded to the accumulator, and after the one rotating command, the A is 29 hex. And if we do this operation with rotate right with carry, the result will be 14. Okay, as you see here, but carry is set. In the lecture, I said you don't consider the carry. So if we clear the carry, and if we want to continue this operation divided by 2, the result will be A. So we have to clear carry flag. Carry flag cleared, and then rotate right with carry again. The result will be 0 a hex. Okay, until this line, and the result is a divided by 2, it will be 5. As you see here, result is 5, and result is 5. Okay, we have already checked on the calculator, Hasan. We don't have any problem.